Bacteria. Bacteria are extremely small living things. While we measure our own sizes in inches or centimeters, bacterial size is measured in microns. 1 micron is 1,000th of a millimeter. A pinhead is about 1 millimeter across. Rod-shaped bacteria are usually from 2 to 4 microns long, while rounded ones are generally 1 micron in diameter. Thus, if you enlarge a rounded bacterium 1,000 times, it would be just about the size of a pinhead. An adult human magnified by the same amount would be over a mile tall. Even with an ordinary microscope, you must look closely to see bacteria. Using a magnification of 100 times, one finds that bacteria are barely visible as tiny rods or dots. One cannot make out anything of their structure. Using special stains, one can see that some bacteria have attached to them weary-looking hairs called flagella. Others have only one flagellum. The flagella rotate, pushing the bacteria through the water. Many bacteria lack flagella and cannot move about by their own power, while others can glide along over surfaces by some little understood mechanism. From the bacterial point of view, the world is a very different place from what it is to humans. To a bacterium, water is as thick as molasses is to us. Bacteria are so small that they are influenced by the movements of the chemical molecules around them. Bacteria under the microscope, even those with no flagella, often bounce about in the water. This is because they collide with the water molecules and are pushed this way and that. Molecules move so rapidly that within 1/10 of a second, the molecules around the bacterium have all been replaced by new ones. Even bacteria without flagella are thus constantly exposed to a changing environment.
Icebergs. Icebergs are among nature's most spectacular creations, and yet most people have never seen one. A vague air of mystery envelops them. They come into being somewhere in a faraway, frigid waters amid thunderous noise and splashing turbulence, which in most cases no one hears or sees. They exist only a short time and then slowly waste away, just as unnoticed. Objects of sheerest beauty, they have been called. Appearing in an endless variety of shapes, they may be dazzlingly white, or they may be glassy blue, green, or purple, tinted faintly or in darker hues. They are graceful, stately, inspiring, in calm sunlight seas. But they are also called frightening and dangerous, and that they are, in the night, in the fog, and in storms. Even in clear weather, one is wise to stay a safe distance away from them. Most of their bulk is hidden below the water, so their underwater parts may extend out far beyond the visible top. Also, they may roll over unexpectedly, churning the waters around them. Icebergs are parts of glaciers that break off, drift into the water, float about a while, and finally melt. Icebergs afloat today are made of snowflakes that have fallen over long ages of time. They embody snows that drifted down hundreds or maybe thousands, or in some cases maybe 1 million years ago. The snows fell in polar regions and on cold mountains, where they melted only a little or not at all, and so collected.
Plate tectonics and seafloor spreading. The theory of plate tectonics describes the motions of the lithosphere, the comparatively rigid outer layer of the Earth that includes all the crust and part of the underlying mantle. The lithosphere is divided into a few dozen plates of various sizes and shapes. In general, the plates are in motion with respect to one another. A mid-ocean ridge is a boundary between plates where new lithospheric material is injected from below. As the plates diverge from a mid-ocean ridge, they slide on a more yielding layer at the base of the lithosphere. Since the size of the Earth is essentially constant, new lithosphere can be created at the mid-ocean ridges only if an equal amount of lithospheric material is consumed elsewhere. The site of this destruction is another kind of plate boundary, the subduction zone. There, one plate dives under the edge of another and is reincorporated into the mantle. Both kinds of plate boundary are associated with fault systems, earthquakes, and volcanism. but the kinds of geologic activity observed at the two boundaries are quite different. The idea of seafloor spreading actually preceded the theory of plate tectonics. In its original version, in the early 1960s, it described the creation and destruction of the ocean floor, but it did not specify rigid lithospheric plates. The hypothesis was substantiated soon afterward by the discovery that periodic reversals of the Earth's magnetic field are recorded in the oceanic crust. As magma rises under the mid-ocean ridge, ferromagnetic minerals in the magma become